Hello students, before you get started on the notes today, I'd like to remind you that tomorrow we have a quiz on interpreting intercepts and interpreting slope. You can glance back at your notes, but please recall that slope is a rate of change, something per something, cost per dollar, miles per gallon, or in some of our examples from yesterday, gallons of water per time or per minute was what we measured the last sample from yesterday in. So slope is how it's changing over time or according to whatever our x variable is. Intercepts. Our y-intercept measures our starting amount. Where are we at time equals 0? Or where are we when x is 0? Excuse me. The x-intercept, on the other hand, is where is our value when y is 0. So whatever our y quantity is, what is the other value when that is 0? Some other things important for today. We're first going to write down in our notes our topic for today. Writing equations using slope and intercept. Remember, we should write this down in our journals, as well as including it in the table of contents. I'll give you a moment to do so. Alright, so in order to work with writing equations, we must really be proficient in understanding the form of the equation. Y equals mx plus b is our slope-intercept form. This is essential for your understanding for the remainder of our unit. So once again, slope-intercept form is y equals mx plus b, where m represents the slope and b is the y-intercept. When we're writing equations, we must have a value to plug in for m, and we must know our slope or our y-intercept value, our b value. So instead of having the variable m and the variable b, we need to have a value for our slope and a value for our starting point. And so these are the two pieces that we're going to work to identify and then plug in their appropriate place. Our rate of change, our starting amount. Slope, y-intercept. Please bear with me while I work on changing the page, getting that set up. All right. Thank you for your patience with my makeshift iPad stand here. So our examples are all going to have the same directions. Write the linear equation with the given conditions. And so if we know our slope and y-intercept, what does that look like in linear equation form? And so our first sample, if m is 7 and b is 2, what does that look like? Remember, we said the only step we have to do today is plug m in next to x and plug b in as the number by itself. So in y equals mx plus b form, 7 is taking the place of m, and 2 is taking the place as b. We're putting the numbers in their appropriate location. I'd like you to try this one, please. And we'll compare in just a moment. If slope is 2/3 and our y-intercept, or b, is -3, please write an equation in the form y equals mx plus b. Once again, slope of 2/3, y-intercept of -3. And so let's compare. 2/3 should go in for the m, which is before x, and -3 goes in for b. Now you could have written this differently. You could have said y equals 2/3 x plus -3. Plus a negative and subtraction mean the same thing. And so it is equivalent to y equals 2x minus 3 is the same as y equals 2/3 x plus a -3. As long as we put in the 2/3 next to x as our rate of change, and the 3 by itself, it's in an appropriate location. Now let's investigate this one. We haven't talked about this one yet, but we know that m of -1/2, that has to go next to x. That's our rate of change. And we're given a point, 0.5. Let's think about that point. 0.5. We have a 0 for x. When there's a 0 for x, that's how we found our y-intercept. So that means 5 is our y-intercept, or our b value. So instead of just saying that b equals 5, you could know that it goes through the point 0.5. Whenever you see a 0 in the x position, that is the corresponding y value is the y-intercept. So knowing this, we can plug in. Our m is -1/2 and our b is 5. So y equals -1/2 x plus 5. All right, so we're going to look at another example. And the directions for this example are going to be write the equation of the graphed line. Oh, that means we must have the graph pasted in. So go ahead and paste in your graph. Just like our other samples that we worked through, the key components we must know are the slope, our m value, and our y-intercept, the b value. So let's take a look. The y-intercept, where does it cross the y-axis? So the dark line crosses the y-axis, the up and down or vertical axis, where? And they clearly marked that point for us, 0, 7. So that means that our y-intercept is 7. Then we need to think about our slope. Our slope between 0, 7 and 1, 9. Well, to go from 7 to 9, that means I had to go up 2. And to go from 0 to 1, I went right 1. So our slope is 2 over 1, or 2. Then we can plug into their appropriate location and end with y equals 2x plus 7. So that means our graph is starting at 7, and our rate of change is that we're going up 2 for every 1x. Let's take a look at a word-based problem, a real word-based problem. And so we'll give you a moment to jot down the situation, and then we'll write the equation. So our example says, write the linear equation that represents the situation. The average baby is 51 centimeters at birth. And yes, I looked this up. Also, the average baby grows 2 centimeters, so just under an inch, per month for the first 6 months of their life. So once again, the average baby is 51 centimeters at birth and grows 2 centimeters per month in the first 6 months of life. So in order to write the equation, we need to think about which one is the slope, or how it's changing, and which one is our starting amount, the y-intercept. I'll give you a moment to think about that and jot down the situation. So which one is our starting amount for the y-intercept? Does the baby start at 2 centimeters or does the baby start at 51 centimeters? Hopefully these words here, at birth, help you think that that's starting amount. So 51 is our y-intercept. 2 centimeters per month. This word per identifies that it's a rate of change. And so our slope is the 2. So our equation for this situation is y equals 2x plus 51. If I plugged in 4, that would tell me how long the baby is after 4 months. And 2 times 4, 8, add the 51, we get 59. So after 4 months, the baby would be 59. Or I could plug in 1.5, representing 1.5 months. What is the average baby? Now, averages could be quite different. Think about that in the real-world context. Some people are taller than others, and so they'll grow at different rates. They'll start at different amounts. But for our average newborn, we can model the equation or model the situation using the equation 2x plus 51.